Welcome back and thank you for joining. Let's take a look at some examples of simplifying algebraic expressions given in radical form by first converting them into expressions with rational exponents. So let's get started. Example A, we have the square root of x to the power of 3 multiplied by the third root of x. First, we'll need to write these radical numbers into exponential numbers with rational exponents. And for this, we have to first identify the index. So here we go. We're going to write x to the power of 3 square rooted as x to the power of 3 over 2. So the power of 3 sits in the numerator, and the index 2 will always go in the denominator. In a similar way, we will convert the third root of x into exponential with rational exponent. Remember, the presence of the radical sign indicates that this is a term with rational exponent. So that means we have x to the power of a fraction. The index of 3 will always go in the denominator, and x has a power of 1, so the power of 1 will sit right here. So the rest of it is simple multiplication of exponential numbers with the same base. So we have the product of two exponential numbers, which means that we're keeping the base the same, and we're adding the powers 3 over 2 and 1 over 3. So as you can see in here, the denominators are different, so we have to make denominators the same as the lowest common denominator. And we have x to the power of 9 over 6, that's 3 over 2 with denominator 6, and 1 over 3 is 2 over 6. Now we can add the two fractions since they have the same denominator, and that would be x to the power of 11 over 6, and that would be the answer. Next, we'll look into example B. You can try this on your own, or you can continue watching the explanations. So we have the fourth root of 81x to the 5 multiplied by the third root of 8x squared. So we're going to convert both these terms into exponential numbers. So 81x to the power of 5, got to keep that in brackets because the entire radicand will be to the power of 1 over 4. So power 1 over 4 multiplied by 8x to the power of 2, so the entire radicand has to sit in brackets here, to the power of 1 over 3 because the index is 1 over 3. So next we'll have to apply the power of 1 over 4 to each part of the term inside the bracket. So 81 will be to the power 1 over 4, and number 8 will be to the power 1 over 3. X to the 5 to the power 1 over 4, x squared to the power of 1 over 3. So let's write this down. 81 power 1 over 4, x to the power of 5 times 1 over 4, that's a power law, multiplied by 8 to the power of 1 over 3, x squared to the power 1 over 3, which would be multiplication of 2 with 1 over 3, 2 over 3. So next, we'll continue with multiplying every part of the term. Remember that numbers are easily multiplied together, and the variables with the same base, exponential numbers with the same base, variable base, will multiply together. So therefore, here we have 81 to the power 1 over 4 times 8 to the power 1 over 3 times x to the power of 5 over 4 times x to the power of 2 over 3. So next, we will have to evaluate each number. So for this, we simply use a calculator. So 81 to the power of 1 over 4, all you have to do is type 81, type power in the calculator, and when you find, and for the exponent, you have to open brackets and write it inside the brackets, and that is because the exponent is in rational form. If we don't use brackets, then the calculator will recognize 81 to the power of 1 and then divide the answer by 4, which most likely will give you the incorrect answer. Now, some calculators will recognize the bad math, so we'll show you on the screen exactly the power that you are inputting, and that can help you, but most calculators don't. So to make sure, always keep the power in brackets, the rational power in brackets. 81 to the power of 1 over 4 equals 3. 8 to the power of 1 over 3 is 2. And now we can combine these two terms of the same base. So the base is x, and we add the powers. That's because of the product rule here. So 5 over 4 plus 2 over 3. So we need to add these two exponents. They have their irrational form, different denominators, so we have to make denominators the same as the lowest common denominator. So we'll multiply 5 over 4 by 3 over 3. So the denominator now is 12. And we'll multiply 2 over 3 by 4 over 4. So now the power will be 8 over 12. So let's rewrite this expression in a more simplified form. Now we're allowed to multiply these two numbers. Very easy to. 3 times 2 equals 6. And then we have x to the power of 15 over 12 plus 8 over 12. Now, you can actually skip this step and then just write the final answer, but I prefer to show the work in here on how we are working with the rational exponents. So now, the next step, we have 6, we have x, and then 15 plus 8, which equals 23 over the common denominator of 12, and this would be the answer. So we're going to continue with one more example. So this time we have the fourth root of a3b5, everything to the power of 1 over 2, multiplied by the third root of a squared b4, everything to the power of 2. So the first step, we're starting off with writing the radicand. Bring the radicand to the power of 1 over 4. So write the brackets in here. So the fourth root becomes index 4 of the radicand. And then the entire thing here will be to the power of 1 over 2. And for this, we'll have to use another set of brackets. So I chose the square brackets to the power 1 over 2. And then multiplied by, we have a squared b4. We got to keep that in brackets because we're bringing it to the power of 1 over 3. So radical, index. So radical, index goes right here. And the entire thing will be to the power of 2, which means that we'll need another set of brackets. So I use the square brackets in this case. So next, we'll have to do a little bit of work with these exponents. So you can either multiply these exponents in here first, or you can apply this exponent to every part of the expression in the base. Now, I will multiply these two exponents in here first because it's less work. If you apply 1 over 4 to both parts of the expression in here, then you have to apply 1 over 2 to both of them. Whereas when you combine the exponents, then you can very easily apply this combined exponent in here. Plus, not to mention that according to bad maths, we have to do the exponents first. Now, let's continue. We're going to write a3b5 to the power of 1 over 8, and that would be the product of these two. And then a2b4 to the power of 2 over 3. Now, it's time to apply this exponent to every part of the term, so therefore we're going to have a to the power of 3 over 8, b to the power 5 over 8, multiplied by a squared to the power of 2 over 3, which will be a to the power 4 over 3 eventually, and b to the power of 4 to the power of 2 over 3. So multiply the powers. So next we'll simplify the exponent. So we still have a to the power 3 over 8. We can change nothing for this. And we're going to bring the exponential terms with the same base closer to each other to prepare them to combine together. So we have a to the power of 4 over 3 coming here. And then we have b to the power of 5 over 8 multiplied by b to the power of 8 over 3. So now we'll have to combine these two powers, a to the power 3 over 8 times a to the power of 4 over 3. All we have to do is add the powers times b, and make the denominators the same, obviously, since we're at it. And the lowest common denominator of 8 and 3 is 24. So we're going to multiply this by 3 over 3, this by 8 over 8. And we're going to do something similar with this group of terms, with this multiplication. So we have 5 over 8 plus 8 over 3. So the lowest common denominator, again, is 24. So we're multiplying by 3 over 3 and by 8 over 8 in here. So the expression in a more simplified form will be a to the power of 9 over 24 plus 32 over 24, multiplying b to the power of 15 over 24 plus 64 over 24. So let's continue with the next step. We're going to move on here. Let's keep a clear view of our previous step. So what we have in here is a to the power of, we combine 9 and 32, keep the denominator the same. So that will give 41 over 24. And b will be to the power of 15 plus 64, which is 79 over the denominator of 24. So this would be the final answer. I hope this made sense, and thank you for learning with me. Bye for now.